Hello, I'm Jihao Zhang from Michigan State University. I'll present our CVPR 2026 paper towards Intrinsic-Aware Monocular 3D Object Detection. Monocular 3D detection predicts 3D bounding boxes from a single RGB image, a cheap and deployable alternative to LiDAR. But existing detectors share a critical limitation. They are trained under a fixed camera intrinsic. When deployed on a different camera, accuracy collapses. As shown here on Kitty, state-of-the-art detectors like MonoDetter, MonoDGP, and Monocope perform well on the seen focal length, but degrade sharply on unseen ones. The root cause? They treat camera intrinsics as raw numeric inputs, with weak inductive bias for intrinsic-aware reasoning. Our key insight is that intrinsic variation is not a numeric difference. It is a perceptual transformation. As you see in this figure, the same object at the same 3D position looks very different under different focal lengths. A longer focal magnifies the object and compresses the background. A shorter focal shows a wider scene with exaggerated perspective. These are perceptual outcomes that humans and large language models can describe in words. So instead of feeding raw numbers to the detector, we encode intrinsics through how they perceptually reshape the image, using language. This brings us to MonoIA. It has 3 modules. The intrinsic simulation module expands training to cover diverse focals. The intrinsic encoder converts numeric focal values into language-grounded semantic embeddings via large language and vision language models. The intrinsic adaptation module injects these embeddings hierarchically into the detector at both feature and query levels. For each focal length, we prompt ChatGPT 4o to generate N descriptions that capture the perceptual effects: field of view, perspective distortion, depth compression. We embed each description via CLIPS text encoder and average them into a single intrinsic embedding. The result is a perceptually continuous space. Numerically close focals become semantically close embeddings. Raw numeric encodings shown on the left have uniformly high similarity, no geometric structure. Our language-grounded embeddings on the right form a smooth, ordered space. To inject this knowledge into the detector, we use a lightweight connector, a 2-layer MLP, that projects the frozen semantic embedding into a learnable visual space. Then we apply hierarchical fusion at 2 levels: feature level, where the intrinsic embedding is added to backbone feature maps, and query level, where it is added to object queries used for 3D prediction. At inference, our hybrid interpolation strategy synthesizes embeddings for unseen focals from the nearest 2 seen ones, zero retraining. This design unlocks dramatic generalization. We train on only 4 focals, 700, 900, 1100, and 1300, and test on 13 unseen ones, including extrapolations beyond the training range. MonoIA achieves the highest 3D AP across every focal length. The advantage widens as focals drift further from training. At focal 1400, Monocop gets 11.11 AP, MonoIA gets 16.99, a plus 5.88 gain, more than twice the accuracy of MonoDGP. Intrinsic awareness also unlocks multi-dataset training. Existing detectors like Monocop drop significantly when mixing datasets with heterogeneous intrinsics, from 23.98 to 17.26 on Kitty when adding new scenes. MonoIA scales from 24.4 with 1 dataset to 26.5 with 2 to 28.9 when trained jointly on Kitty, new scenes, and Waymo, a plus 4.46 gain on Kitty Val. On standard benchmarks, MonoIA sets new state-of-the-art results. On the Kitty test leaderboard, we surpassed the previous best, Monocop, by 1.18 on moderate AP3D. On new scenes Val, we gain 1.48 on easy. And remarkably, this comes with only 0.13 million additional parameters, same G-flops as Monocop. 3 takeaways. First, intrinsic is not a number, it's a perceptual transformation. Second, language grounds geometry. LLM descriptions plus CLIP yield a smooth intrinsic space that supports interpolation to unseen focals. Third, MonoIA achieves new state-of-the-art on 3 benchmarks, generalizes to unseen focals, and scales with multi-dataset training. Project page, code, and models are available via the QR codes. Thank you.